Hello, everybody. This is Mr. Kusaj, and we're back with part 2 of chapter 1.5. Now, remember, ignore the date. Use today's date. This is from another time, so ignore the date. So today we're going to finish 1.5 and talk about transformations. Okay, transformation, just like the English word, it's when something transforms into something else, right? Changes into something else. Well, here we have three types, and we're going to talk about each one of them. Now, transformation of what? We're talking about transformation of graphs, of functions, right? So if you remember, in part 1, we were introduced to the parent graphs. Really quick, don't copy this. There was this one, right, straight across. There was this one, straight line but diagonal. Then there was the parabola, okay? Then there was the snaky one like that. Then there was the V1, and 1, 2, 3, 4, what else was there? Oh yeah, then there was this one that just started 0 and just went up one direction like that, curved. Oh yeah, then there was where we don't touch the 0, like that. Remember that one? Okay, these were the parent graphs. So what we want to do is transform them, meaning somehow change them. They keep their basic shape, but change them. Like, take this one, for example. Maybe we can like squeeze it and make it more narrow, or stretch it out, or maybe move it up or down, or left, right. Okay, that's transformations. And we break it down into three types. So the first type is called translation. Not transformation, that's a different word, translation. That's when you slide across, left to right, or maybe you slide up and down. But you don't change the shape, you just slide the whole thing. Okay? Here's an example. So let's say this is our function. The dotted one is our original function. Okay? That would be the parent graph, okay, the original graph, just f of x. By the way, this would be x squared, right? What if we add a number on the outside of the function and the end of the function? Just add a number. What that would do would be to raise it, just slide it up, okay? So it would slide it up. And if you take away a number, it would slide it down. How many? Well, it depends on your number. If it's plus 2, you slide up 2. If it's minus 2, you slide down 2. Okay? So the slide or the translation is 1. But remember, you can slide across also. Right? Here, if we add a number on the inside like that, plus h or minus h. So this is kind of tricky. We can ask in class why this is so, but if it's plus a number, then you move to the left. If it's minus a number, you move to the right. So if this was plus 3, you'd move 3 to the left. If this was minus 3, you move 3 to the right. And we could talk about that in class, but you just have to remember it for now. So that's one transformation, sliding. Okay, here's an example. Right? This function is f of x equals absolute value of x plus 4. So you remember the parent graph of absolute value of x. That was the V shape. Well, we still start with the V shape, but now we slide it plus 4. Now, would that be up, down, or left, right? That would be up, down, one of these situations, right? How about this one? X plus 3, but on the inside, the plus 3 is on the inside. Would that be slide up, down, or left, right? That would be left, right. And by the way, it's left. Remember, we just talked about that. How about if you do both? Well, then you do both. You slide down 1 and over 2. Okay? So I'll give you time to copy this. But the first thing you should do is, in dotted form, the original, right? The parent graph. Okay? Now, the first one, f of x, was what? Plus 4. So 1, 2, 3, 4. The whole thing just slides up. The whole thing just slides up. G of x is plus 3 on the inside, so that means left 3. That would be this one. It's the same graph, but slide it over. And minus 2, minus 1, that means to the right 2 and down 1. So you take your parent graph and slide it to the right 2 and down 1, and that's h of x. Right? So these are just examples. As soon as you see absolute value, you know it's going to be a V shape. These other numbers tell you where to put it. Okay? Let's look at another type. Reflection. Reflection is just that, when you have some sort of mirror line and you're being reflected. Well, we talked about symmetry. It's just like that. You can reflect or flip, we can call it flip, right, over the x-axis or the y-axis, right? Do you remember this graph, by the way? This was the square root graph, huh? Well, if you put a negative in front of the function, what you'll do is flip it over the x-axis, right? Because you remember f of x is really y, so you're making that y negative. So same thing, same distance, but on the other side, below. If you make the x negative, right, on the inside, if you make the x negative, then you're flipping over the y-axis, right? It's the same x, but now it's negative, so it comes over here. Okay? That's called flipping or reflection. The last one is called dilation or stretching. That is when you put a number in front by multiplying, right? A number in front of the function, a multiplier. Okay? Now you remember this as, let me cover this one so we can concentrate on this one. You remember this as x squared, right? Yeah. So the dotted one would be the original x squared, just f of x equals x squared, plain. But soon as you multiply a number in the front, it's going to stretch it and make it more narrow. It's going to squeeze it here like that. Okay? That's assuming your number is greater than 1. Okay? You could also stretch it out like that. Right? You start with the x squared, plain x squared, and then you can stretch it out. That's when your a is less than 1, but greater than 0. Right? Like half or a quarter or a third. Right? Less than 1. Another way I like to look at this is, remember x squared? This was 1, 1 right here. Well, imagine this is like some sort of speed. Right? So f of x is some speed. And if you multiply, then aren't you making it faster? So instead of just going up at some speed, it's going up even faster, right? But this one, you got some speed, but now you're multiplying by a half or a quarter or some number less than 1, so you're slowing it down. You're not going as fast, you're slowing it down. Okay? So below these graphs, here, a is bigger than 1. The multiplying number is bigger than 1. Here, a is between 0 and 1. Some fraction between 0 and 1. Okay? Let's see an example, and we'll be done. How would you graph this? Right? Well, let me get some scratch paper. Well, I know x to the third looks like this, right? Where you go through 1, 1, right? That's x to the third. This is 2 times x to the third. So twice as fast. So I'm going to be going twice as fast up, twice as fast below, right? Let's make it a little neater. That's not much neater. So if you look at the dotted one, you go through 1, 1 here, -1, -1, 1, 1 here, right? That's the plane x cubed. That's the plane x cubed. We want to go twice as fast. So when x is 1, right, the function is 2, twice as fast. Not 1, 1, but 1, 2. And same thing here, 1 and then 2 down. Okay? So how about this one? Now we know what x squared looks like, right? We know what x squared looks like. That's this one, right? But this says 1/4 of x squared. So we're going to slow down. So this would be 1, 1. We want 1/4 of that. So we want to slow down. We don't want to go up that fast. We want to slow down. Okay, so you know what's coming ahead. The way we do these is first, right, in dotted, make the x squared, really quick, make the x squared, and then stretch it out for the function that you do have, that you do want. Okay, so the dotted one would be x squared. 1/4 x squared is the solid one here. Okay, so for class, when I see you, when we get together, in your book, just go to page 48 and look and try these two problems, 3A, 3B. They'll match the notes. It'll just be a different function, but they'll match the notes. So just do what we did in the notes, okay? All right, under 12 minutes. All right, see you in class. Bye-bye.